Hi everyone, welcome to this demo of BT's Aperture tool. This is a tool that we use to improve the understanding of our business processes and aid our process improvement teams in making BT operate as efficiently as it possibly can. The tool is used across the BT group to help all kinds of process teams in all kinds of different processes and is not specific to telecoms, can be used in any business or in any process where data is available. It's the availability of data which is essential and not the type of process that you're looking for. And we like to say that Aperture makes processes visible and measurable. This allows you to monitor them in the long term and also to keep an eye on changes to make sure that they're doing what you expect them to do. Once you've loaded your data into Aperture from your process system, you'll be able to be presented with this dashboard screen, which is just arriving on the screen right now. This shows you some high-level statistics about the process in question and enables you to sanity check the data that you've imported. It's designed to give you a quick read on essential statistics and not to replace any existing dashboard solutions which you might have. So if we look here, you can see that in this demonstration data set, I have 794 faults, or process instances as we call them in a generic way, 5,000 individual activities, and interestingly, 309 different ways to get through the process. That's a measure of consistency, which is useful, and I'll talk more about in a moment. The most important chart for us, though, really on this screen is the one in the center of the top row of graphs. It's this duration chart. This allows us to see where the time is being spent in our process and what the distribution of process time is like. So if you look at the bars, we can see the most common process time is 5 days, so 5 days to complete. And there's just a shy of 220 orders that complete in that time. The line shows us the cumulative distribution, though, as we go over time. And the shape of that line allows us to tell whether we have lots of short processes or lots of long processes, whether we have a long tail. So actually here, if I hover over this 5-day bar, you can see that 78% of our faults are fixed in this demonstration set in less than 5 days, which says that the other 20% are indicated over that longer tail out towards 27 days. This is a typical style of Pareto analysis, which is very, very useful for us to work through. The process model view, which I'm showing on screen here, is really the centerpiece of Aperture. And this is the main view where most of our process improvement people will spend the bulk of their time applying their domain knowledge of our processes onto the data that Aperture is showing. And what we have here is a visualization of all of the fault data in this demonstration set provided on a single diagram. All of the activities are represented and all of the flows between activities are also represented. You can see this looks quite complicated even in a simple process like this one. But what we can do is break that down by color and by activity. So the gray lines that you see on the screen here, these connect to the start and the finish. So these allow us to isolate how are my processes starting, what's the first thing that we do to them, or where are the processes completing, where do they come from, how are we ending up? So that we can answer with the gray lines. The blue lines indicate when an activity is happening for the first time. So that's as we would expect to go through the process. For example, here we have an arrow that goes from auto configuration test down to hold for retest, which is a perfectly acceptable piece of process behavior in this example. The red arrows indicate repetition. Now, this is really useful for process people to find out where we have inefficiency in the process. Those red arrows really bring that to life. And in addition to both of those, the thickness of the arrow relates to how often that happens in the process, which is also recorded in the parentheses, which you'll see there. So looking for large red arrows is a very quick indicator of repetition and where you might want to really dig into your process. You'll notice that this diagram does look quite complicated. So we provide a pruning option which allows us to take out low frequency behavior that we are less interested in. So if I prune this diagram out here to 50, that will remove anything that happens less than 50 times, allowing me to concentrate on the main process behavior. And you can see that's really tidied up the diagram for me. There are lots of drill down options in here, some of which I'm showing on the screen right now, that help our process people to really dig into the detail of how things are working and really get right down into the nitty-gritty of it, and deliver better outcomes for our customers. Another useful view of the process data is this unique paths view. You'll recall earlier on I mentioned that there are 309 different ways to do this process, even though there are only 800 actual faults in it. And this is where we would get under the skin of that number. Each of those 309 different ways of the process has a row in this table that's on screen, with the most common one at the top. So if I click on that, Aperture will show me that view, and that shows me the nice linear view that I expect. You'll also see in the table there's a happy path and unhappy path column. Now this path here is happy. This is what I want to see happen. So I can tell Aperture that by clicking on the small smiley face. We can now look at the second one. Again, this is actually a happy path in this case. So I can indicate that. So this allows us to investigate different types of activity. So I've clicked here on the fourth one. This is 2.2% of our process volume. And you can see here there's a number of repetitions in the process data. And this is not something that I want to see. So hopefully you can see here how a process person would use this to see what the most common problematic patterns in the process would be. And then they can then drill down into the data to work out what process improvements need to be put in place to correct that problem. Aperture uses AI techniques internally in a number of places, from how it discovers the connections in the process through to the clustering view that you can see on the screen here, and then the prediction algorithms that we can build on the top of its data. The clustering view that's on screen discovers subgroups within the process that help us to discover the reason why things happen. So if we look here, we can see that, for example, in the first cluster on the left, clear code type R3 occurs more often than we would expect. So that might be a driver for this behavior. In the third cluster, we can see that this particular report code, NSC, occurs 50% more often in the fourth cluster than it does anywhere else. So again, NSC might then be driving that behavior. This gives the process teams another view on it. And in terms of prediction, Aperture gives us a standard way to reason with process data, and we can use that as a basis to make predictions. And BT has predictors that can predict the next event in a process activity, what date and time that activity will occur, and how likely that is to lead to success for the customer. And this allows us to monitor proactively and manage our process systems to ensure the best customer outcome.